of our series, that's Learn SQL Server in 60 days. Last video we have seen how we can query and how we can write query for outer join, and what are the different kind of outer join we have in a SQL Server. Right, just to recap, we have three type of outer join in SQL Server. First one is left outer join, second one is the right outer join, and third one is full outer join. Full outer join is a union all of both two, right? Great. I think you all know about those things. Those who haven't seen that video, you can go back and you can watch this video, Learn SQL Server in 60 days, day 10. Now I'm going to start a new video, and this is day 11. In this video we'll be talking very important things. There are the following points I am going to cover in this video. Those are equijoins, self joins, cross joins. Natural joins are there, but these joins are not present in SQL Server, so I won't take it. But these are a few joins I think I need to discuss because we are covering joining concept. Great. So equijoin is a join which contains equal to operator in his condition. I'm repeating my statement. Equijoin is a join which contains the equal operator in his condition. Statement. Great. So you may have a question then how I can write equijoin. Let's say if I want to write inner join, then I use the keyword called as inner. If I want to write the left outer join or right outer join or full outer join, I use the keyword called as the left, right or outer. So if I want to write equijoin, do I need to use any kind of keyword, or is there any kind of keyword which I can use so that I can easily identify this query is equijoin query? No, actually equijoin statement doesn't have a query, it's a concept. If you are using any type of query and the condition part is having the equal to, then that kind of query we can call as equijoin. That kind of join we can call as a equijoin. So equijoin can be written with the inner join, equijoin can be written with the outer join, right? That is left, right and full. So equijoin is a join when there is a condition called as equal to in the condition of a join query. That time we can call that query as a equijoin query. Just to example, we are having a two table called as the employee detail, right? EMP. I am joining this table with the company table. EMP. Now I'm writing condition, right? So EMP table is having a column called as the company ID, and company also having a column called company ID. Now if you carefully observe the condition part, in the condition part we are using a condition called as the condition operator called as equal to, right? So if we are using any operator like a equal to in any kind of join query, that kind of join we can call as the equijoin. Great. Next is self join. Self join name itself suggests that when we will join a same table with each other, that's, let's say for joining anything we require two table, right? So we can call it as a table A, and we can call that another table called as a table B. So when we are joining a table A with a table A only, remember, underline this one, when we are joining table A with a table A only, then that kind of join we can call it as the self join. So you may have a question, then why I need to join same table with the same table? Sometimes it's required that the dependent value is based on the same table, right? So we will have some master table. Inside a master table again there will be some parent column, and that parent column again depend on that same table, right? What I mean to say, let's say we are having one table. This is table A. Table A is having a column called as ID, right? This is column 1, and it also has another column called as a parent ID, right? So let's say parent ID and parent parent id is a primary key for this column, and sorry, id is a primary key for this column, and parent id is another column which contains the parent for that respective id. Great. Now if you'll observe here, this id is a identity column and this parent id is the another column, derived column, but that is the dependent on the id column basically. Great. Now when I'm writing a query in such a way that I want to see the id along with the parent id, right? So now I want, what my query is, now my query is I want to see the id of a respective row. Along with that I want to see the id of parent id. Try to understand, id of parent id, id of parent id. If I want to see the id of the parent id, then I need to join one table with another table, right? So how will I write the query? I can write the query like select star from tab table A, table 1. Here we need to use left join because it depends actually, because when we'll join the table, if it is inner join, then it will give me only a match record, but I want to see all the data from the table 1, right? And if basically it will return, but normally we go for the left join. So like this table, this is just example, I'm not giving you a real-time scenario actually, this is just example to understand the self join. The table 1, this is alias B. When you will join like this A, here we'll add some condition, right? Here id is equal to b of parent id something, and we can add one more condition so that we'll get the data in a such a way that we'll use the same table 2 times in a join query. Maybe it is a bit confusing, but you can ignore it. Just remember that when there is the join between the same table, you just need to say this is a self join thing. Cross join is very important. In cross join, what happens when there are 2 tables, that's a left table and the right table, so each row of each table will combine with each row of another table. Let's say we have the table A and it has 2 record, and another table called as B, it has a 3 record. So the first record of the first table will combine with the 3 record of another table, then second record will also combine with another 3 records. So we'll have the 6 record if we'll use the cross join for this kind of scenario. Great. So these are all about joins. Hope you understood the different kind of join. Cross join is very important when we want to have unique data. I can say let's say you have a date data, for example, and those data you want to send to the reports, and there you want to generate some dynamic column. That time cross join is used, or sometime also it is useful basically. So cross join is just joining some static data with a live data so that you can access that data by row by basis, right? Syntax is very simple. You just need to write like this. There is no condition, you need to use cross join. You will get all the data. That's all employee will be linked with all the company. Great. Now next is subquery. What is subquery? Subquery is the query which name itself suggests that it's a sub of query. So this is again a query, but this query is the subquery basically. Try to understand. This will be a child query. I can say this will be an inner query for the outer query, right? Subquery is a query which is a child query, I can say, or or dependent query. Basically, correlated subquery is a subquery which is again a inner query for a respective outer query, but it has the condition, and that condition part will be depend on the parent query, right? Next, for a correlated subquery, you can go through my video. I have created a separate video for correlated subquery and subquery. You can get a lot of idea there. Next is exist versus not exist. So exist versus not exist we use in the condition when we need to write a condition in such a way that in some of the data set we want to verify that a specific record is present or not. Instead of writing count star and instead of writing any other way, we go for exist or not exist. It gives a good performance when there are a lot of data and we are comparing with a very big table. In versus not in. So I think exist means we'll check that particular entry, that particular record or that particular condition is present in other table or not. Not exist means it will just check it is not exist or not. Next is in versus not in. So in is also very important when we'll write a query. In a condition part, sometimes we require to verify a few list of things, that if we want to say I want to have the ID 1 2 3 and thus these IDs are present in the column called as ID, so I can write in 1 2 3, right? I also want to verify that this ID should not be present in my respective condition, so I can write like not in 1 2 3. So this is just for condition, but when we'll try to write actual query, we people can get a better picture how to write this inner in and not in, exist and not exist, union and union all. So basically I think we miss union and union all. Union is just combining the same, is just combining a multiple data set with a one data set. What does this mean? When we'll combine a multiple, let's say I have a 3 select statement, I want to get only one select statement. So how could I write that? I can write like select first statement union second union third one, so I will get the one result set. Next, union all. Union all will not do any kind of sorting, any kind of distinct operator. It will simply give me all the data. Let's say in table 1 I have a 2 record and in table 2 I have the 2 record again, right? And those 2 record are exactly similar with the table A. So when I am writing union from table 1 to table 2, table 1 union with table 2, then I will get 2 record, but when I will write union all, I will get the 4 record. That is the basic difference. Hope you understood difference between different kind of things like exist, not exist, in versus not in, union versus union all, and correlate subquery. Then we have covered cross join, self join, outer join, inner join. Right? Hope you like our video regarding this part, and please subscribe if you like our video, and thanks for watching. Have a great day.